IEEE 754 standard for the float and double real number representation. So real numbers that are the float and double that are not storing like similar way like integer I is equal to 10 and normal decimal or the character value. So it's standard IEEE 754 standard. So what is exactly the standard? So real number have two things. One is the exponent and one is the significant. And sign is useful for the negative or positive number. Sign is 0, that means is a positive number. Sign is 1, that means is a negative number. Exponent is a 8 bits and significant is a 23 bits. So like this way our 32 bits will be made and double will be 64 bits, 1, 11 and 52. So there is one bias, that is the for 4 bytes we have a 127 in decimal and 7f in hex, 3ff, that is the value is 1023. So first convert number into the binary format, then convert binary into the standard exponent format. What is standard exponent format? 1.x e raised to plus or minus y. So what is x? X is the significant, e raised to plus or minus y. So if my binary is 1011.1010, then I have to do 1.x e raised to plus or minus y. So 1.0111010 e raised to, I have shifted three numbers after point. So my e raised to plus 3. Suppose I have shifted point before number, here nothing, 0 point like this. So my number will be e raised to minus 3 like this way. How many numbers you are doing right at that the plus 3, my left side it's a minus 3. So we have to add or subtract exponent part with the standard bias number. So whatever the plus 3 we have to addition with our standard bias number, that is the 127. So 130. So whatever the binary of 130 will be go into the exponent portion, and significant portion whatever the x part 0111010, this part will come to the significant number and rest of all are the 000. So we have take the example of 3.7. So what is the binary of 3.7? 11 dot 0.7 multiplication with 2 is 1.4 like this. So 0.4 multiplication with 2, we have to go till 1.0. But what happened here? Here my 0.2 multiplication with 2, 0.8 is continuously repeating. So if continuously repeating, so we will stop there and we will make here bar. So our binary is 101100. Then we will make 0110 bar. So that is the continuously repeating. Similar way we have did this, convert the binary into the standard exponent format. So 1.11010 bar e raised to plus 1, then 127 plus 1, 128 binary is going to the exponent portion and significant portion is 10110. So that is the continuously repeating part. So next today we will see the initialization of a pointer. So syntax is data type star variable name is equal to address. So this is the first part and dotted line is the second part. So first is the declaration of pointer. A second one is the storing address of pointer. So data type star variable name we have already seen, integer star p. P is equal to address of I. Suppose I want to write this two line in single line. So this is my declaration, this is my storing address of pointer. So I will write like this. So integer star p is equal to address of I. Here p is storing the address of I, not star p. So in this case integer I is equal to 10 suppose, and integer star p is equal to address of I. Here p is storing address of I, not star p. Okay, I'll write down this first. So next, suppose I will write here integer I is equal to 10, integer star p, and star p is equal to address of I. So this is correct sentence or wrong? So how to make it correct?
Either P equals to address of I, or int star P equals to address of I.
Yes. So we have to remove this star. So this is wrong. If we will write like this way, compiler will generate error. But how to correct it? So we have to remove the star, and this is not right way. to storing the address. Suppose I will write like this way: integer I is equal to 10, integer star p, and p is equal to I. Here we have to put address. So this is also wrong. Here we have to put address. In third case, suppose I will write integer I is equal to 10, integer star p equal to I, and star p is equal to 20. So here how to make correct? Here we have to put address. So write down these three things. Mostly people are doing mistake here. If we want to store value, then we have to write star p is equal to 20, not p is equal to 20 is wrong. Star, that means we have to store the value. We have to access that address we have stored data. So as we already seen in past lectures. Next, different types of pointer declaration. There is two type. One is the constant and second one is the volatile. So these both are the type qualifier, constant and volatile. We have already seen the volatile. So what is exactly the volatile and why we are using the volatile? So yeah, next we will see the constant. First we will complete constant in normal, then we will move to the with pointer. So constant itself tells we will make our variable as a constant. Suppose I will write constant integer I is equal to 10. Then I will do I is equal to I plus 1 and printf I. So what will be value here?
10.
So here it will generate an error. Once you will use constant as a variable, you cannot modify that value. If you will try to modify that value, compiler will generate error. So here it, it will generate error in this line. Why? Because I take my variable as a constant and I am trying to modify my value. So my compiler will generate error. So write down constant is informing the compiler that I wants to make I as a constant. If by mistake I modify the value of I, please generate an error. This is the way compiler is generating error. Once you will take constant, you cannot able to modify value. You can initialize data at the time of declaration. So you can store data at the time of declaration. Suppose by mistake I have taken the constant integer I and I am trying to storing some value in I is equal to 10 or anything. Here it will generate error. So whenever we will take constant, at the time we have to store value initialization time. So my value should be I is equal to 10, I is equal to I plus 1. Here it will generate error. So at the time of initialization, we have to assign data. So we will see one this program. Teacher I is equal to 10, then I is equal to I plus 1, then printf percentage I is equal to percentage D, comma I. So what will be my value of I here? Here I value is 11. This is our general program. I is equal to 10, I is equal to I plus 1 and printf I. So my I value will be 11 here. So I value will be 11. Now suppose I will take integer I is constant I is equal to 10. Now my compiler will generate error. See, error assignment of read only variable I. So now whenever we will take constant, so my variable will become read only format. Okay, write down this program. So whenever you want to make your variable data secure, no one can modify that data. So at the runtime, no one can modify the data. Your data is fixed. You want to use only as a read only purpose. So at that time, make that data as a constant data. So next we will see different methods using the pointer. So our title is different types of pointer declaration. So now you understood the constant. So first is the constant integer star p. Second one we will see is the integer constant star p. Third one is integer star constant p. And fourth one constant integer star constant p. So these four methods we will see one by one. Then I will go. So you will write down from here also. So I will make there is the four different programs. P50.c. So first one is the constant integer star p. I will write down my program is like this way: integer I is equal to 10, constant integer star p is equal to address of I, and here I will do star p is equal to 100. So once we will do constant integer star p. So here I am doing the integer I is equal to 10, constant integer star p. So I have taken my pointer as a constant integer. So I have written the constant as the before integer. You can write as the after integer. This is the second method. Yeah. So both are the same. First and second method, both are the same method. So before and after. So I have taken my pointer as a constant. Here I am doing the p is equal to address of I. Here I am just storing the address, and here I am modifying data. So in the case of constant integer star p, we can only read it. We cannot able to modify data. So once you will take your pointer as a constant using const integer star p, you can only read, you cannot able to modify data. If you will try to modify data, compiler will generate error. So in this case, constant integer star p, we can only read it. We can't able to modify data. So what is the meaning of read it? So if I am trying to modify data, here my compiler will generate error. In VS Code, here if you put your cursor at the red line, expression must be modifiable L value. So that is the error will come. What is the meaning of read? I will write down here printf star p is equal to percentage d comma star p. Here I am the reading the data whatever available at that location, and I am printing that data. But I am not trying to modify that data. Whatever that data is, I am reading only. So here it will not generate any error, and it will give the whatever the value of I. So I will run this code. So my star p value is 10. Suppose I will do here star p is equal to 100 in my code. Where compiler will generate error. Assignment of read only location star p. So in book write down this. We cannot. So here we can only read it. We cannot able to modify any data. So in the case of constant integer star p. Okay, I will do now modification. Suppose I will take j is equal to 20, and here p is equal to address of I and star p. Then here suppose I will do I is equal to 100, and suppose I will do p is equal to address of j and print up the value of star p. So what will be the my output here? So here once we will do constant integer star p. So this is my I, this is my j. I address is 1000, j address is 1004, I data is 10, j data is 20, and this is my constant integer star p. P is storing the address of I. So whatever the address we will take, that address here is constant. So we cannot able to modify that data using star p because we have take our constant integer star p. So whatever the pointer is pointing to that address is taken here as a constant. So here as a constant, not here constant. We can make in the pointer my address is constant. So my pointer is pointing to address of I. We cannot able to modify that data. Here I can able to change my data of I using I because I is independent. I have no dependency on pointer. Pointer is indirectly storing that address. So here I can modify my value using I. Using star p it's not possible because I have taken the pointer constant. Here I am storing the address of j. So I modify my address. Instead of address of I will pointing to address of j. Here it's not modified. So this is also possible. So we are changing the address in the pointer, not value. What is the meaning of constant integer star p? We cannot able to change data. That is data will be in read only. So we can only read it, but we can able to change the location. So my pointer is pointing to address of j. Now my value is 20. Here it's 10. Suppose I will print here I, so I value will be 100. So we can able to change the location, but we can't able to modify that data. Here I cannot able to do star p is equal to 200 or anything. If I will do, then my compiler will generate error. So star p is equal to 10 and star p is equal to 100. Sorry, 20. I have not put here slash n. Okay, then complete this program. So this program is same for the second part also. Integer constant star p, both are the same. You can take constant before integer and you can take constant after integer. So both are the same. So suppose I will take constant after integer. I will write down here star p is equal to 100. Then my compiler will generate error. Same error, same thing, anything is not change. So you can take constant before integer or constant after integer. So using this, we can't able to modify data. We can only read the data. We can change the locations. We can able to take read data from there, but we can't able to modify that data. Our third case is the integer star constant p. Here, what is the difference? So previously in first and second case, we have taken the integer constant star p, constant integer star p. Here we have put constant in between the star and p. Code for that: integer I is equal to 10, j is equal to 20, integer star constant p. Then here I will do p is equal to address of I, then printf percentage d slash n comma star p. So this is called exactly constant pointer. So previous one integer constant star p star constant integer star p, that is the things about the constant in the pointer. But here exactly the pointer is constant because we have put constant in between the star and p. So what is the meaning of this? We can't able to assign data or storing the address after initialization. So this is the constant pointer. So pointer can point only one location. That should be at the time of initialization. Once we will take our pointer as a constant, so it can point to only fixed location. So write down these things in your book. It can point to only fixed location. Constant pointer must must be initialized at the time of declaration. So here I have taken integer star constant p, and here I am trying to do p is equal to address of I. So here it will generate error. So integer star constant p pointer is a constant pointer. It can point to fixed location. At the time of declaration, we have to write down here integer star constant p is equal to address of I. So here it will not generate error. It is pointing to only fixed location, that is the I location. Here you can read that data, you can modify that data, and you can do anything with that. But you after that you cannot able to assign data, assign address to pointer. Suppose I will try to assign data address of I or address of j, any location, so it will generate an error. So here I can I can't able to modify address. I can able to modify data. So in first and second case we can't able to modify data. That data will read only. Here my address is read only. Okay, I will run this code. Here is assignment of read only variable p. So we can't able to assign data after initialization. So here you can do p is equal to address of I. So integer star constant p is equal to address of I. Then here I am doing the star p is equal to 100. Here my value of star p will be 100. So here I can able to modify the data, but I can't able to modify the address. So I have to put address at the time of initialization. So my output is 10 and 100. And suppose I will do here p is equal to address of j, then it will generate error. So we cannot able to modify address. to the I or J or anything. So that is the fixed location address. We can able to read that data. We can able to modify that data, but we can't able to change our location. So your location is fixed at the time of initialization. At that time you can use the constant pointer integer star constant p. At the time of initialization you have to assign that address. That will be the constant. You can't able to change that address. The pointer will point to only fixed location. So write down this, then we will see the next. So fourth method is the constant integer star constant p. Here this meaning is the we can't able to modify data and can't able to modify address also. So you can't able to modify that data, you can't able to modify that address. You can only read it. So I will write down this. Integer I is equal to 10, comma j is equal to 20. Constant integer star constant p. Here suppose I will do p is equal to address of I, printf percentage d, comma star p. Here my compiler will generate error. Constant integer star p expression must be modifiable L value. So here we cannot able to modify address. Suppose I will do star p is equal to, here I will do is equal to address of I, and star p is equal to 100, and here also it will generate error. Expression must be modifiable L value. So we cannot able to modify data and we cannot able to modify address. P is equal to address of J. This is also not possible. Star P is equal to 200. Anything, this is not possible. We can only read it. And I will run this code. Here at the time of initialization, we have to assign the address similar as integer star constant p in third case, but in third case we are able to modify the data. In fourth case we are not able to modify the data. We can only read it. If you want to only read the address data, whatever the written at that particular location and fixed location that, so you can use constant integer star constant p. Here you cannot able to modify that address. Here you cannot able to modify that data. Only read the data. On read only format. So once we are storing our file in the format of read only, so it is similar like this way. You cannot able to modify any data. You cannot do anything in this. You can only read it. So write down this program. I will ask you the some little bit tricky question. Suppose I will do integer I is equal to 10 and j is equal to 20. So you know this all the four methods. So I will take first one, constant integer star p and normal integer star q. I have taken two pointers and I will do p is equal to address of I and q is equal to address of I. In this case you can't able to modify the data. Constant integer star p. You can able to access the address. So here p is equal to address of I and q is my normal, that is not constant pointer. So q is equal to address of I. So here I will do q star q is equal to 100, and then after in printf I will print percentage d comma star p. So what will be my value of star p here?
10.
10.
10. 10.
So here this is my I, this is my j. Sorry, I will take only I. 10 location address is 1000. This is my p and this is my q. So here I am storing the address of I and here also I am storing the address of I. But my this pointer is constant, so that can access only that address and read only that address. So here we can't able to modify the data. But this is not a constant and it is also storing that address. So here we can able to modify the data. So my data of address of I am here modifying that 100. So here it's modified to 100. And here we can't able to modify data, but we can able to read that data. So here I suppose I will read that data. So data that location is the 100. So my output is 100, not 10. For this pointer, this location is read only because the pointer is constant here. But for this location is not read only stored because this is not a constant pointer. Here in P50, I will modify this integer star constant star P, integer star Q, and here P is equal to address of I and Q is equal to address of I. Star Q is equal to 100. I will remove this code. So star P is 100. That is the indirect way to modify data using pointer. If one pointer is constant, so you can take another pointer, and so this is the tricky questions. We are not generally doing like this way. So that is the no meaning of this star P. Suppose we have seen our normal data constant integer I is equal to 10. So we cannot able to modify this data, ith data, because my normal variable is 10. Suppose I will do I is equal to 20 or I is equal to I plus 1. So at that time my compiler will generate error because your value is constant. Suppose I want to modify that data. So how we will modify? So what is exactly I is stored at the 1000 location and data is 10. So using I we can't able to modify that data because my variable I is a constant. But we have that address and we can add using pointer modify that address data. Suppose I will do here integer star P and P is equal to address of I, then star P is equal to 100. So I have modified that data location and then I will read that. So I get the 100 data. So that is the indirect way to modify that data. Similar here, this is the indirect way to modify the data. Okay, write down this in your book. This is only for today.